So if you want to learn about data engineering, data modeling is one of the topic that is absolutely very important, and today we are going to understand about very important concepts, or we are going to talk about, break it down, what exactly is data modeling, what are the important concepts, what are the important things. On a very crisp video we will be talking about those things. That is what exactly is a fact table, dimension tables, grains, star schema, snowflake schema, SE type 1, SE type 2, and someone demanded this in the comments, so you can also comment down and ask any sort of things in the comments, so that any suggestions if you have of videos or anything that you want to ask, you want to get, so please ask it. As you can see on the screen, let's start with the first thing, that is data modeling. Okay, I'll just make a today we'll be talking about all these things, that is what exactly is your fact table, dimension tables, and it is more than enough. These things are more than enough to build your foundation and to be a very good data engineer and think on a very good perspective. Whatever solutions will be you will bring, then it will be much better. Okay, so firstly we'll talk about what exactly is a data modeling. Okay, what is data modeling? So let's talk about that. Suppose you have a e-commerce business. Okay, you have some customer tables are there. Another table that you have, that is say orders table. Okay, orders table. Similarly you have one more table that is called as payments table. Okay, similarly you have one more table called as what, called as your order items table or something like that. You have multiple like things basically where you can store your data, and separate things are there. So basically these are, on a data engineering point of view, you can just query or just do all those sort of things and you can get some sort of data, right? So basically my question is, basically suppose you are a business. Okay, or business asks you to get, like business will not need these tables directly. Okay, they will need revenue by month, revenue by city, or top products, so that they can take their decision, total revenue, in which particular area they got more revenue, in which particular area they got least revenue, so that they can improve their strategies. So all those type of questions you have to reply. So how exactly you will do that? For analytics, we usually need to restructure this data into simpler models. You cannot directly store like this and directly query here. Okay, on the single table only you are storing all the customer records, on the single table only you are storing all the orders records. It will bloat up, it will be very difficult then to query on, because slowly gradually the data will increase, right? So basically that is called as data modeling, to break down this table into important aspects, like for analytics, restructuring this data so that it can be more useful. That is called as data modeling. Okay, so first we will decide what? So first decide the grain. Basically what is grain? Before creating any kind of fact tables and dimension tables, what are these? So fact tables first, let's talk about the fact and dimension, then we'll talk about the grain. So firstly, whenever we talk about fact table, what exactly is a fact table? This you will usually hear. What is your fact table? So a fact table says basically that whatever, okay, now whatever fact table, these will have the values we usually aggregate. The fact table will majorly what this particular it is a type of table. Any kind of table can be a fact table, but what those type of table will include or will store, basically it will store the business events. I'll give you an example also. Business events and any sort of things that is measurable values, and examples like quantity of any kind of this orders I want to store, sales amount. Okay, sales amount I want to store some kind of discount. Okay, I want to store some sort of profits. So that will be any sort of, these are called as measures, numerical data. Basically you'll be storing inside the fact table. And whenever we talk about dimension tables, what exactly a dimension table stored? Dimension table. So the dimension table will describe whatever values are there in the fact table, how it is related. Okay, so basically it describes the fact table data. How it describes, basically, like example if I give you, basically what type of data will be there in the, suppose we are talking about dim customer. Okay, dim customer, suppose dim dimension table customer is there. So basically what type of data will be there in this? Like coil of customer key column will be there, or customer ID. Okay, or say customer name. city of the customer will be stored. All those kind of things will be stored into the dimension table, by which the fact tables can be linked, and it can get you all those important things. Describes your fact table. Dimension table describes your fact table. Okay, it is very important. If you are storing some sort of, say, product details in the dimension table, dim product if you are having. Okay, so in the dim product, what all type of product if you are having, what all things will be stored in this? Some sort of product key will be there, product ID will be there. Okay, that describes the product and the fact sales, not fact sales, the sales this one. Like you can connect to the main fact table and directly get some sort of data. So basically that is called as dimension tables. Okay, so if we talk about these things, like how exactly this is linked, so basically you will be having one fact table in the middle. Okay, or there will be one fact table on a very high level that will be having mostly the numerical data and the keys by which you can link the different sort of dimension tables, and separating to that there will be multiple dimension tables. Dim tables will be calling dim table, dimension table, like customer, dim fact, dim customer, dim all those sort of things will be there here, and this will be connected directly like this. It will be connected via any kind of key, relevant key, and there will be one fact table, there will be multiple dimension table. This, and usually this is called as star schema. Like you are having one fact table in the middle, and you are this separated via like this. Okay, dimension. So basically that can be called, and here basically it can be having product dimension, product table. Okay, it can be dim customer, dim order. Okay, so like this it can be. So the fact table sits in the center, and usually in in the star schema, this is how it looks like. So basically in the middle there will be a fact table, and it will be surrounded by the dimension tables. Okay, very important. So why it is useful right now, let's talk about that. So because business queries becomes very simple now. If you know this particular layout or schema detail, there is one fact table, it is linked via this two dimension table, linked via this two dimension table, linked via this. Like suppose it has order ID, by the order ID you are connecting this table. Okay, say by the customer ID you are connecting this table, and by the product ID you are connecting this table. Okay, if you have these all details, how it will be just easy for a data engineer to figure out from which particular table to connect which table, and if you want to get this particular column, how to get that. Like what is the revenue for the product. So what all tables to connect, the product table and the fact table. If you connect these two tables, you will get that if by month I want to get which customer has got most sales, or who is the most valuable customer, which two tables I'll connect, the fact table and the dim customer, right, via the customer ID. It becomes so simple, right? That is how things become simple. Okay, so this is called a star schema. This is a star schema. I'll just write it here, not here. I'll enclose everything into this thing and write it above that. This is blue, send it to back, and this we'll call it as, this is called as basically star schema. Okay, very important. This is called as star schema basically. Okay, so these were the main things, like fact tables, dimension tables. These are the terms basically. Let's talk about green. What exactly is green? First, decide what is green. So we know about what is a dimension, what is a fact. Fact has mostly the numerical type of data, mostly the measures like quantity or sales amount, all those kind of order amount, those kind of thing. Dimension tables will have description of these numbers. Like in the fact table, suppose they have order amount, order things. So how exactly you will link to which which this amount, suppose 500 rupees is there for the order. So which product is of 500 rupees, you have that will be there in the dimension table. Okay, so you have to connect the fact table with dimension table to get those things. So that is how it is connected, and that is how data modeling comes into the place. So for what does this represent? Your green, basically, before creating any sort of fact tables, for our sales model, one row barabar, like whenever we talk about a row, like a row in the table, so one row is equal to one product in an order, right? Whenever one row will be there in the fact table, that means that row should be linked to any kind of order, one row, one product in one order, right? In the product table, basically. That is how the linking has to be done via the fact and the dimension tables. So basically, whenever we talk about, like, say, order has, example, if we say order like 101 has keyboard, mouse and laptop, then we will have 3 rows in the sales table, right? 3 rows will be there in the sales table. Like for the laptop, there will be one, there will be for mouse, there will be keyboard. Okay, there will be 3 rows. Similar 3 orders will be there for this one. We will be having 3 different rows. There will be 3 different rows, or more than that also, for in the fact table, the amount, basically, that will be there in this one. 3 different for orders in, if it is there. So here also it will be there. That is how that is called as green. The definition is called as green, and this is very important on the interview point of view to understand ki basically what is green in data modeling. So green in data modeling is ki basically whatever one row, if you have in the fact table, the same one row should be there in a dimension table also. Or if there are 3 different rows in the dimension tables, the 3 different rows should be there in the fact table. Like how many, what is the amount of this, what is the amount of this, what is the amount of this. Okay, that is how it is different. So these are the major ones, basically, that we are talked about. So next thing, basically, let's talk about this one, surrogate key. What is a surrogate key? Whenever we talk about surrogate key, let me tell you. Surrogate key, what exactly it is? This is very interesting. Okay, you might have heard about primary key, alternate key, foreign key, all those type of keys, unique key, non-unique key, indexes, all those type of things. What is a surrogate key? Surrogate key says, basically, suppose you have a customer ID. Okay, suppose you have a customer ID, say 101. I'll write it. Customer ID, say 101. If you have this. Okay, you have some customer ID column in the customer table that has 101. Okay, inside the warehouse, we may create customer key. Similar to this, you can create a customer key. And this 101 represent 500, something like 501, suppose. Whenever we talk about 101 or this one, the warehouse generated, like this is a warehouse generated key. Basically, for this corresponding key, there is a warehouse generated key that is called as a surrogate key. Okay, it is a business relevant key, or not a business relevant. Basically, it doesn't, basically a surrogate key doesn't make any sense. Basically, that like customer, if I say customer ID 101, you will find some records 101, and business also knows for this particular customer will have some records. But whenever we say customer key is our surrogate key. Okay, so basically this is a business, this is a warehouse generated key, and this is called as surrogate key. It doesn't have any business importance. Why not only use a surrogate? Like if you want to use, many people will think, basically, why exactly we are not using the customer ID only? Why not use this? Why not use this? Okay, that is a question that you'll be having. So because whenever a source ID, whenever we are talking about the customer ID, source ID can change, because source ID can change. Multiple sources may have overlapping keys. It is a data warehouse. Okay, so there can be multiple sources. Multiple sources can bring multiple keys. Multiple keys means multiple customer IDs. 101 from one source is coming, 101 from another source is coming. That can happen. We need historical tracking also. So dimensions basically commonly use whenever we talk about dimensions, dim tables. So they will be having these type of keys. Like if you talk about BU, every BU or business unit, suppose you are talking about say orders business unit, so orders business unit order key will be there. Okay, some sort of keys, product key will be there. Similarly, your customer key will be there. So like that. So that is the meaning of your keys, surrogate key. So let's talk about next one, that is your SCD, slowly changing dimensions. Let's talk about SCD. What exactly is SCD? So whenever we talk about SCD, slowly changing dimensions. Now suppose you are working, suppose this is SCD1. Okay. Suppose there is a table. Let's take an example from Sheets. On a like this, I'll show you. Suppose there is a customer, employee. We'll increase the font of this. Not this much. Little bit less. Okay. Suppose we have say employee and like say city is there. Okay. So suppose two information is there of this particular employee, like 101 and say employee name also. Name is there and city is there. Suppose right now Anurag is there. Okay. He is working in Bengaluru. Okay, suppose he working in Bengaluru. Tomorrow what happens, this particular person got transferred into another place. Okay, so what happens, someone in the company just updates this to Pune. Again what happens, another day or another year, he got promoted, he went to where? New York. What happened? The Pune and Bangalore data got overwritten and the city got updated to this one, that is your particular New York. Okay, so this is SCD1. What happens is whatever data was there, just update it to new city. Okay, New Delhi. Then he came to New Delhi. So what is happening here? The previous data, whatever was there, that is not being tracked. It is just being overwritten. The older value is getting overwritten. There is no history of it. So whenever we talk about SCD type 1, this is SCD type 1. Whatever you are having, you are just updating into new value. Whatever you are having, new city came, just update it to new city. Okay, there is no history tracking. There is no history. To be very honest, we use like SCD type 1. Majorly we don't use it. Whenever you want to use a SCD type 1, in that particular case, history is not important. Like say email IDs this person is having. So some email ID difference came. Okay, so basically that email ID previous one was not valid. So we just override it to new one. Or customer name, like in this one someone wrote like this, so we can just update it like this. So these are incorrect attributes. So that what is happening, basically we are just updating it. But say suppose there is a business constraint where I want to also store the history. History means I want to keep something basically that also has history. So what I'll do, I'll create one more column or some kind of a like flag column. Basically what I'll do, suppose this person is in Bengaluru right now. Okay, what happens, now this person got, this is called as SCD type 2, slowly changing dimension type 2. So what happens, he got moved to where? Pune. So what I'll do, I'll update this is to 0 and this will be 1 now. Now again what happened, this person shifted to New York. Okay, he came to New York. So what will happen now, basically this has to become 0 because it is not active now. New York has to become active, that is 1. Similarly this person again what happens, he again came to New Delhi. Okay, so now what happened, this one became 0, that is inactive, and this became active. So now if I want to identify where Anurag worked to which all places in last 5 years, 6 years, I can see whichever are inactive. I will see whenever the data is active, like is 0, that means that person is not right now, he is not working there. But whatever is active, like if you query on this is active, I want to check the city, current city of the Anurag, so I can directly check. And if I want to check the previous city whichever he has worked or lived in, I can directly check. So what it is doing, it is preserving your previous data also. That is called as preserving your history, tracking you are having. So this is SCD type 2. Okay, I'll just copy this to the notes so that you have the reference of this also. Is your SCD type 2. Okay, So all the notes also I'll be adding, so no need to worry basically. So this was all major things that we talked about. That this time here you can see it is shorter, but in the notes section you will get a free resource also. In the description you will getting a our this resource link. Basically this is all free. I'm not getting anything from here. You will be not getting charged anything. Just you can fork it so that the whole repository you can copy to your own account, and everything you can just copy, download, everything can be done. For the roadmaps we have this. For any kind of Databricks question or PySpark question, interview question, whatever we make the video on or the notes on, I just add it here. Okay, so same kind of things you can do. So this was all about the video. Thank you so much for watching it. If you want to learn everything from scratch, like right now today we discussed about a very crisp video about data modeling. If you want to model some kind of things in a practical way, if you want to learn everything how we think on a data engineering perspective, on a very high level, how things happen exactly, from very scratch, you want to learn about SQL, Python, everything from the scratch, data engineering. If you want to learn, we have an end-to-end bootcamp, data engineering bootcamp, DataX data engineering bootcamp. In that we have all the fundamentals covered, we have all the things on the interview level covered, we have multiple modules in that. Particular technologies has different separate modules. You can learn everything, and everything is self-paced on your ease. You can just log in, learn, and do the practice. Everything can be done. So this was all about the video. And also we have live Q&As. If you have any sort of doubts, so you can connect with me live. We have live group sessions and all, where you can ask your questions, ask your doubts. So this that is how things happen. Okay, so link is there of the bootcamp in the description. There is a coupon code just for you guys. Use it. It is for only limited time. Use it right away. Other than that, we have the WhatsApp link. Doubt, if you have any sort of doubts related to bootcamp, you can directly reach out there. Or if you have any sort of doubts, you can, or any demands for the next video, you can add it in the comment section. Thank you so much. Bye bye.